All right, so we're gonna start this week with the a new cipher. Last week we did the just a simple XOR binary cipher. Pretty simple on the N cipher, a little bit harder on the D cipher, but still definitely uh, not the hardest stuff that we're gonna do for the remainder of this cryptography unit, which, by the way, I'll go ahead and announce here. It will wrap up, and we will be finished with cryptography before cohort 3 starts. So I will teach my last cryptography lesson the week before cohort 3 starts, which is next week. But we're going to go ahead and get started on what we have this week, which is the linear feedback shift register, LFSR, I believe is. And I'm going to start with a very abstract version of it, and this is sort of I will link the original video that I'm using this abstract example from. But we have the top row. Actually, I will not be in REPL today. I will be showing the core function of the cipher in this Google Sheet, and then you will take the. It's a similar layout to what it was the cipher last time, but it's just creating a different key stream. So we're gonna get started, and we have these very simple faces here, and we're just gonna give them like set a rule, right? Because they don't really know if they want to wear a hat or not. So we're gonna say that our very happy guy, he is gonna wear a hat. He's gonna wear a hat whenever he sees the regular smiley face wearing. That's supposed to be a baseball cap. Please excuse my crude typing. Um, but whenever he sees him wearing that. So whenever he looks to this guy, if he's wearing that baseball hat, he's going to wear a hat the next day. And if we go to the next guy on our list, we have this face right here, this surprised face, and he's going to wear a hat tomorrow if he sees that his very happy friend over here is wearing his baseball cap. And we go to the last face here. I did not forget about the first one, but I'll get back to that. This sort of neutral face. He doesn't sure if he's gonna wear a hat or not, but if his surprised friend is wearing one, then he's gonna wear one the next day. Now, the first happy face isn't really sure when he wants to wear a hat either, but he's not gonna just copy. He's gonna look, and he says, "Well, if this guy." If this guy, or we're going to get our other friend here, or if our surprised face or our neutral face, if one of them, but not the other, is wearing a hat, then the happy face will wear a hat. So if we take our first row, and we're just going to say, he wore a hat the first day, and he wore a hat the first day, he did not wear a hat, and then he did wear a hat. So I'm just going to go through, like, by hand, do a couple rows here. So the first thing we can see is we start with our happy friend over here. He looks over, he sees, oh yeah, he was wearing a hat. Now he puts on a hat. This guy looks over, oh yeah, he was wearing a hat. Now this day, he is going to wear a hat. You go across the list, he looks over, nah, he wasn't wearing a hat. Wearing hats isn't cool anymore. And we get over here, and he looks and he sees, oh, he isn't wearing a hat, and he isn't wearing a hat. So neither of them are wearing one. So he won't wear one either. And then you can sort of see where this is going as it goes down the list. Now this guy sees, oh, he isn't wearing a hat. That's not cool. He looks over. Oh, yeah, he was wearing a hat the previous day. So this very elementary idea here will carry over. Looks back up there, and he is going to wear his hat. So this is using a hat idea, right? But essentially, we're looking, and let's just say no hat is a 0 and a hat is a 1. Well, then this can become binary, and this will be what we'll be using to generate our key stream. And this right here will be called our rule. So if we go back over to here, you can see where I have set it up with binary. I've hidden this key because this has like the automated version, but we'll just kind of open this up and we'll just kind of open this. We have our rules here. If we look at this, we can see, okay, so B1, that's this guy, he'll wear a hat if B2 prime, the previous rendition of B2, is wearing one. So then that would become a 1. B2 looks if previous function of B3 had a 1 or a 0, and it copies. B3 looks at B4, copies. And this is where I'm starting to show my code here to help this out, make it a little easier. Instead of going through by hand, you can do that, but it takes a lot longer. If we just look here, I have these, this is called a reference in Google Sheets. And basically when you have the equal sign and then a bar, a cell is what these are called, it'll just set this cell equal to that one that you're referencing. So if we look over here, it's referencing that one. Look over here, it's referencing this one. But this over here, this B4, it does not have one. This is basically what does the different function. So if you look, and we can do it by hand, and we have all this filling out, so we only have to fill up one row. And we say B1, and if we have a plus in binary, you're assuming XOR. So we can look here, 1, 1 is 0, next row. 0, 1 is 1, next row. And that's all right. You can start to go and get it. 1, 0 is 1, 0, 1 is 1, 1, 0 is 1, and then 0. And you can sort of see how this is. You can, once you've got it going, you can get a roll going. But that's not really super efficient. So I'm just going to delete that. And what we're going to do is to show, I'm just going to give it a bit of code here. So I will type it out. I'll just type it out here. Oops. So it equals if. How if statements work in Google Sheets is if conditional, comma, true output, comma, false output. So the conditional will be bit XOR, which is just using bitwise XOR for binary. And then our first that we're looking for, our first value will be this C2. And then comma to separate it. I just looked up the function to see what syntax it uses. And the second one that we're using the XOR function for. So now this is our conditional. If that is true, then if our XOR, well rather, if our XOR of those two is 1, 0. Basically this is saying what the XOR is, and that's just what it'll output. So now it did it automatically for us. But this is where we have this little blue box here. If we drag this down and we fill down, it'll carry through. And now we're actually getting some good quality filling out the chart. We're doing it quickly now. You aren't going to be filling out a chart, but this is just to illustrate. What's important here is this is called the seed. The seed is what goes across the top. The rule that's important is this rule. You can assume everything will shift 1 over to the right. That's what the S in LFSR stands for. Shift over to the right one. And then this is the actual rule that's important. It doesn't have to be this specific rule. It could be B5. Yes, 5 is B2 XOR 3 XOR 4. And it could be any varying level of difficulty. So here's your seed, here's your rule, and this produces your key stream. Now you only need to generate enough keystream as you have characters. So if we have our word here is, we'll just say it's dad that we're trying to do. We're just going to stick to our regular binary, and we're not going to go into ASCII yet. But binary will turn into D, if you remember, is, hang on, this is A, B, C. So I'm guessing that's D. All right, and then A would be 5, and then D again. So that's our binary, 15 ones and zeros. So then normally you would only generate up to 15. And that is useful because now we have, this is our key stream. So if we go through and we take what was up here, 1 1 0 1 0, 4 ones and a 0, and then I need to get one more row actually. So we'll just put that down there. Put that down there. Bam. Okie doke. And then 0 0 1 0 0. So now we have our key stream and our original plain text. Basically, this cipher will do is just take the sum, the XOR of those, and then you'd go through. I don't have a binary to plain text converter handy, but it would just be, that's our XOR of it. You'd convert that, and you're done. So the only difference between this cipher and that last week's binary XOR basic cipher is that you have to generate a key stream, which makes it that much more secure because it's not just, if you remember the last week, your cipher was just one letter. And that isn't very secure because every single plain text is being moved by the same amount, the same shift on the XOR. So the challenging part will be to create this key stream when you're given a seed and a rule. I'll go ahead and show another example here of a potential rule. I'm just going to go ahead and make it live so that I can sort of show, what it could end up looking like. It's a bit of a process. Like I said, you won't be on Google Sheets. Well, you can be on Google Sheets. That's fine, but you want your cipher to be all combined, and the function creates the key stream and then does it as well, instead of manually inputting your seed and rule and key stream, because there's a whole lot of user error if you're moving stuff around from different programs. And then we're just going to say our rule is B5 is, we'll say B3 prime plus B2 prime plus B1 prime. So now we're just going to say, again, you don't have to know how to use Google Sheets for this. It's perfectly fine. I'm just doing it to show what's going on here a little bit easier. Just going to drag that over here, drag it over one more. And then we'll just say our rule. This is where we put our function in. And this is really all that you're going to have to code. You will have to do inside, I'll go ahead and tell you right now before I forget, inside of a for loop, during your Python code, the easiest way to do this, to generate your key stream, would be to have like your B1 and then B1 prime variables, and then after you've done your function, set B prime to whatever B is currently. I'll probably make another video showing exactly what I mean in Python, but for today I just wanted to get you started on the foundations. But we're going to quickly go through here And we're going to go through, just like we had, I'll go ahead and op oop, open this up so you can see that. Exactly what I had there, and that will be open. And our bit XOR, the same thing, as many values as you want, which in this case is this one, and this one, and this one. Now, we haven't done XOR with 3 different binary numbers at the same time, but it is the same thing, just like adding 3 numbers. Instead of just 1 and 1 or just 1 and 0, it's now 1, 1 and 0, which is 0. Just one more step that is where it becomes easier for computers, especially when you have let's say your rule is like B20 and you have 20 of these. It goes across a whole screen. It's just not fun to even program in Google Sheets. So this is where the Python automation will be very helpful. 1, 0, boom. Oops. And it does not like that. So let's go ahead and see. Expected 2 arguments, we got 3. Okay. So this is where I will just do the bit XOR 2 times. So instead of that, I'll just say bit XOR, and then we'll say this guy, comma, this guy. And now it should work. There it is. So it got 0. Next time it should get 0 again. As we go through and we look at it, that is a key stream that we've just generated. If we went up to however many we were looking for, not really sure how far it goes, right there evidently, this would be our key stream. So the key stream for this rule using this seed for this many characters, I think this is maybe 15 characters. We'd go through it, easy peasy. No, this is more than that. So yeah, it's just generating the key stream to however many characters you need. That will again be useful for a for loop, to say how far you're going using the length function on your plain text. This week is only to create the N cipher, because the D cipher is, like last week, the D cipher is just kind of opposite. So if you can prove to me you know how to do the N cipher, you are good to go. I'll just sort of put it out here. You're going to input words, your plain text letters. And I want you to this time output not just your binary. I want you to output the binary and the ciphertext in letters. So that's just one more thing to add, but it is another print function that should be easy enough. As always, if there are any questions, feel free to DM me, and I will produce another video later this week on specifically how this will work, as well as I will link the video that I referenced with this lovely hat example up here, and this it's a lot cleaner looking there than in Sheets, but that's all for now.